Your test will be on Thursday, right? And here's the schedule. Your schedule will be Thursday, April the 22nd. Your test time will be from 8 o'clock to 10:30. Okay, now we will start the check-in at 7:45, maybe earlier. Okay, if I see that, let's say 7:40, I already have like 4 or 5 people, then I will just check in these people and send them the file. Okay, so basically you will see what we do for your test 2 is the same to what we did in your test 1. Okay, yeah, so the test time will be from 8 o'clock to 10:30. Now 15 minutes earlier, you do the check-in, maybe even earlier than that. And you're done with your test at 10:30, you have to submit it by 10:45. Okay, again, just the same to what happened last time. I reviewed the videos that I did last time in your test. I need to emphasize one thing, that your test has to be feasible at all time. Your test paper needs to be feasible at all time. Of course, if you print it out, then you just barely start, right? Okay. Here's the thing. Let me show you what happened last time. And I found some students seems to be, I don't want to say that they are cheating yet, but of these some students doing this, I somehow believe one of them is actually cheating. Okay, let me show you what happened last time. Give me a second. I'm sorry, I look scary. Yeah, so what happened last time was this. So some students, actually, they did it. This is what the view is supposed to look like. Okay, now then, what some students did is this. That person put the paper outside. And then somebody actually put in another paper underneath. And then that person, they put it back. You see what I mean? So that's how that person get the cheat from someone else. You know? Okay, no. Your paper should be all feasible at all time. In a way that, let's say you're done with this page, then you put it behind it. You put it behind it. Okay? Not to somewhere else. Yeah, because what happened last time was I happened to see that that person received a cheat. Somebody actually put some paper in. And then he grabbed this. You see that this is a new paper. This is a new paper. Okay? I purposely use color paper here. So this is this person's test. He put it aside. And then his friend slide a new paper underneath. And then he put it back here. Like that. You know. Now the thing is I did warn that person during the test, and that person didn't admit it. Fine, but it's recorded. You won't survive my second test though. Okay, or my third test. Okay, so no, don't cheat. And I also find some of you actually still try to use photo math. Okay, in fact, get solutions from other monitor. Let me show you again what happened. I was a student before, so how to say it? This is like it's like, okay, if you know how to cheat, then I know your technique of cheating. Okay, I've been teaching for so long and I was a student before. Okay, now here's what happened. That person have a monitor here with the camera. Okay, with the camera. Now the thing is that person have another monitor to the left-hand side. To his left-hand side. That's where he saw the solutions. You see? Okay, so the camera is the one facing him, but he has another monitor actually to the left of him, where when he did the test, he keeps on looking to the left, you know, he keeps on looking at to the left. Now, the thing is, come on, even if you need to cheat, be professional. One thing you don't want to do is this. Don't wear glasses. That's that person's mistake. Because that person wears glasses, then when he sneaks to the left, his glasses actually show that. You know, I'm teaching you how to cheat. Okay, even if you want to do it, right, be professional. Okay, now apparently that person's not doing well at all with his test. Okay, because one of the ingredient of my test is speed. So even if you try to cheat that way, you won't have enough time to finish your test. Okay, that's why I don't extend time. Okay, so that's fix your technique. Most of you are actually okay though. Most of you are actually okay. Where the camera was actually approximately 4 feet away from you, such that I can see your face and I can see your test at all time. Okay, most of you are actually okay with that already. But some students still purposely get the camera way too close, such that my view is too the frame for me is too small. And on Tuesday, I will tell you to move your camera back so that I can see more. Okay. And some of you, the one that the paper actually becomes outside of my view frame. And then I will say something, of course, on Thursday. Okay, your test was recorded. I recorded for my personal use. Okay, so I don't share it. Okay, unless one time I see that you really have evidence on video that you are cheating, then I may share with the ombudsman if you actually appeal my decision. Okay. That's for the testing. By the way, those students whom I think not being honest, none of them actually score more than 80 anyway. You know, so I don't expect you to do okay in your second test if that's what you did. Okay, but at the same time, consider that as a pardon that I give you another chance to do well in your second test and your future tests. Okay, now next, what happened, Thomas, if I cannot make it on Tuesday, Thursday? Actually, if you want, you can do the makeup test on Monday, Wednesday, which is tomorrow, but this is a time. Okay, that's the time. Now I will consider that as a makeup test though. Okay, if you take it different from your schedule. Now, but I think if you want a makeup test, then it will be after the test, right? After your test, which is, it will be on Saturday. Your makeup test will be on Saturday if you want to do a makeup test. Now, that's only for students who have not done makeup tests in the past. Okay, and don't forget that you only have one makeup test quota for this semester in my class. Okay, now your time happens to be exactly the same time with the makeup test time is exactly the same time with your class. That is that the makeup test will be from 8 to 10:30, the same with yours. Okay, the check-in will be done at 7:45, the same with yours. And the submission is 10:45, the same with yours. Okay, so basically what happened on Saturday, if you want to do makeup test, is the same to what you do on Tuesday, Thursday. Okay. However, if you want to do a makeup test, you need to let me know by Canvas email by midnight of April the 23rd. Okay, you need to let me know if you want to do the makeup test. Okay. Why Canvas email, Thomas? Because the next day, 7:40 in the morning, I will reply your email from Canvas. I will reply that with the Zoom link. Okay, the Zoom link may be different from the one you have. Basically, what happened is on Saturday, April the 24th, I will have makeup tests for your class, for Monday, Wednesday class, and some students from Isosceles College. Okay. So students who needs to do makeup tests, I pull them all together on Saturday, you know. So instead of you tell me when you want your makeup test to be, I will be the one telling you when your makeup test is supposed to be. Okay. That's for your makeup test. Any question? It's basically the same to your test one. Okay, except that the way that you appear on your test, for some of you, not all of you, need to be fixed. Okay, your test paper need to be visible at all time. Okay, preferably your face also, but at least your test paper. Okay, that's one. And I have a question earlier from one of my favorite students. Thomas, can you show the solution for test one? Solution for test one already posted. So you go to your assignment, test one. If you're from Monday, Wednesday, I have the solution posted there. If you're from Tuesday, Thursday, I have the solution posted there. Okay, now the direction for your test two already posted here too, but I basically copy paste that from what we have for test one. Okay, nothing really changed except the date, or I think the only thing I changed here is this one. Instead of submit that under test one, you now submit that under test two. Okay, now and then, yeah, one of my favorite student here asked me, Thomas, do you have, can you show us, share with us the solution for all tests, the previous tests? Actually, I did, starting from March the 29th. So if you see Monday, Wednesday discussion, March the 29th, we went over these tests. Okay, so what happened is March the 29th, I did the polynomial parts from these 4 tests. Okay, and then on March the 31st, the same test, but I did the rational function part. Okay, so you can see the solution here. And then on April the 5th, I finish up the rest of those 3 or 4 tests. Okay, fall 20, spring 20 test 2, spring 19 test 2, and spring 19 test 3. And then on April the 7th, we did another new test. Okay, covering polynomial, rational functions, compositional function, inverse function, and exponential functions. Okay, so beside the solutions that you can find on those days, you can also go to their recording if you want to see how I explain those things. Okay, so you will go to event recording, and then you will be looking for the recording from March the 29th. Okay, and then March the 31st, April the 5th, and then April the 7th. Okay, that's, you know how to see the recording, right? Yeah, so I went over those with them. Okay, honestly, I said to her that I was surprised that she didn't know that. I will replicate this again and again for your test 3 and also for your test 4, maybe even with your final. Is it okay? Yeah, try to benefit from that though. So the way I plan this class is basically as the following. The recording for the material, already available was done last semester. So it was done in fall 20. Now then what I'm missing, and therefore I try to record those, I was missing doing problems from the book. Now, then I am able to achieve that in spring 21 this semester through my Tuesday, Thursday class, your class. Now, because I have Monday, Wednesday class, then I have a chance to also do problems from all tests. Which I achieved through spring 21, my Monday, Wednesday class. So next semester, I am assigned to teach 2 pre-calculus classes again. Okay, but at that time, I already have the lecture and problems that I work from the book and problems I work from my old tests. Okay, so next semester, I don't know what I will do in my class because they already have all the recordings. I'll be sitting here and then wait for questions, I guess. Yeah, but that's for next semester. Okay, well, anyway, that's for your tests and how I set up my class. I really hope that you benefit from the structures, the fact that I teach 2 different classes, 2 same classes in the same semester. Okay, I will continue with 4.6. Last time, I think we did problems like number 16. Let me check again. What problems did I do last time from 4.6? So I did number 15 and I did number 26, even number 33. I think I should do more, huh? Let me do more. Do you have any requests which problem to work on page 313? Let me do number 24. Let me do number 24. Log x minus 4 minus log 3x minus 10 is equal to log 1 over x. Now I can make the left-hand side here into a single log. The right-hand side already a single log. This will be log x minus 4 over 3x minus 10 equals to log 1 over x. Now log blah equals log blah means blah equals blah by 1 to 1ness. Then solve it as usual. I will multiply by the LCD or cross multiply. X times x minus 4 equals to 3x minus 10. Get the bomb, get the boom. Happens to be factorable. If it is factorable, you have to factor it. But we are not done yet though. You need to make sure that when you plug in these numbers, the argument stays positive. Okay, now you see that when you replace x by 5, this is positive, right? Positive 1. There will be positive 5. This is 1/5. So x equals 5 is okay. How about x equals 2? When I plug in here, that's log of negative 2. The argument is negative, so no, I have to reject that solution. Cross it out. Okay, so please make sure you check the solutions against the argument, Let me see if there's other questions good to work on. The one that give us ugly answer maybe. Let's see number 22. Number 22, log of x plus 3 plus log of x minus 3 equals to log of x squared plus 5 minus 2. On the left-hand side, I can make it into a single log. In fact, that's log of x squared minus 9, right? Okay. In between, it looks like this. This is log of x plus 3 times x minus 3. You see? Okay. Let's skip that one step. Oh, but we have some problem here. We have log on the left, but on the right hand side, I have mixture of log and constant. We don't like it. Let's move that log to the left. So we have log of x squared minus 9 minus log of x squared plus 5 equals to negative 2. Make it into single log again. This is log of x squared minus 9 over x squared plus 5 equals to negative 2. Now I have log something equals constant. So I will change this into exponential form. Base 10, right? Okay, so x squared minus 9 over x squared plus 5 equals to 1 over 100. Now then from here, I go on further. Let me cross multiply. I will get 100 x squared minus 900 equals to x squared plus 5. So 99x squared equals to 905. X squared equals to 905 over 99. Now then apply the square root. I will get plus minus square root of 905 over 99. But there are two solutions there. The first one is the positive branch. I think this is okay, right? Later on. But the second branch is not okay. Why? Because it's already negative, and then when I put that into one of the argument, this one here, negative minus 3, there will still be negative, right? So it won't work. In other words, I need to reject this one here. I have to reject that, and this is my answer. Okay. Number 38. Number 38. Log base 4 of x plus log base 8 of x equals to 1. How do we do this? 4 and 8, both of them has common base 2, right? So let's change them to base 2. Okay, so this is log base 2 of x over log base 2 of 4 plus log base 2 of x over log base 2 of 8 equals to 1. Now then log base 2 of 4 is 2. Log base 2 of 8 is 3. Yeah, 2 to the third equals to 8, right? Now then, I will multiply by the LCD by 6 in this case. Then I get 3 log base 2 of x plus 2 log base 2 of x equals to 6. 5 log base 2 of x equals to 6. So log base 2 of x is 6 over 5, or 1 and 1/5. Therefore, in exponential form, x is 2 to the 1 and 1/5, which is 2 times 5th root of 2. Okay, our textbook actually did show, at least in my solution here, our textbook actually does it this way. Our textbook does it this way. From here, it shows that x equals to 2 to the 6 over 5, which is the 5th root of 2 to the 6, which is the 5th root of 64. But I prefer this answer. Yeah, this one here has the power of 5 in there, so it should not be considered simple. Okay, this is the simple one. 2 times square root of 5, 5th root of 2. Now, this is the first time you see questions where the base are different. If the bases are different, what do? Find common base they have. Okay, find common base they have. Number 44, the last question I will do from this section. Number 44. Solve for x. Solve for x. Y equals to e to the x plus e to the negative x over 2. Solution. 2y equals to e to the x plus e to the negative x. So I multiply both sides by 2. But these two guys here, e to the x and e to the negative x, let me make it this. So I rewrite e to the negative x to be 1 over e to the x. Then now I multiply by the LCD again. So 2y e to the x equals to e to the x being squared plus 1. Okay, so 0 equals to e to the x being squared minus 2y e to the x plus 1. Okay, if I use let u equals to e to the x, then we have 0 equals to u squared minus 2yu plus 1. And u will be, u12 will be negative b plus minus square root of b squared minus 4ac over 2. That will be 2y plus minus square root of 4y squared minus 4. Oh, I can factor the 4 out under square root. That becomes 2. So I can reduce by 2, right? So u12 is y plus minus square root of y squared minus 1 only. But u12 is e to the x though. What will x be then? Then you change it into logarithmic form. X is equal to natural log of y plus minus square root of y squared minus 1. Okay. That's for number 44. The rest of this this section here, word problems, where they usually give us the formula and then we just use those formulas. I do one more problem. Something may be useful for you. Number 60. Number 60. A drug is eliminated from the body through urine. Suppose that a dose of 10 milligrams, the amount AT remaining in the body T hours later is given by AT, the amount after T hours is 10 times 0.8 to the T. Okay. And that in order for the drug to be effective, at least 2 milligrams must be in the body. Okay, so AT has to be at least 2 milligrams. Part A, I will go back to that equation, to that formula and explain more. Let me do this first. Part A, determine when 2 milligrams is left in the body. So I need to solve the time where we still have at least 2 milligrams. Divide by 10. Let's apply natural log. Okay, so T natural log 0.8 is greater or equals to natural log of 0.5. I need to put a warning here. Note. Something crucial I need to be careful here. It seems like I apply natural log both sides and I keep the inequality sign, and that's okay. Okay, nothing wrong there. But I need to be make you aware the following. It is true that if x equals to y, then natural log of x is natural log of y. Okay, it is also true that when x is greater equals to y, then natural log of x is greater equals to natural log of y. That's also true, but it is not true in general, not for every base. Okay, not for every base. X, given that x is greater equals to y, okay, it is only true that you maintain the inequality sign if the base is greater than 1. log base p of x greater or equals to log base p of y for p greater than 1. Okay, but if the p between 0 and 1, that is not true. You need to reverse the inequality sign. Why is that, Thomas? Because when the base is positive, the function is increasing. Let me show you the significance. If the base is greater than 1, the log function is increasing in the sense that if A is less than B, then log base P of A must be less than log base P of B. Do you see that? Okay, because the log base P, where the base is greater than 1, is an increasing function. Okay, now notice that it is not true if the base is between 0 to 1. You see, when A is less than B, log base, let's say base 1/2, okay? Log base 1/2 of A is greater than log base 1/2 of B. Do you see that? Okay. So this is when the base P is between 0 and 1. This is when the base is greater than 1. Okay. Remember we reverse the inequality sign when we multiply by -1. Let me write it as a side note. Okay. I will erase this later on. Remember when we have, let's say 2 is less than 5, that one we know. But if we multiply by -1, we reverse inequality sign, right? Okay, and that one is something we already use even from chapter 1. But a better explanation at this point that we can use that is because the operation of multiplying by -1, if we see that as a function, that function is 1-to-1 and the function is decreasing. Y equals to -x looks like this, such that if A is less than B, then -A is greater than -B. Okay, that's the reason. And it actually works for all 1-to-1 decreasing function. 1-to-1 decreasing function. Okay, let's say 2 is less than 5. We know that, right? Now, 1/x looks like this. 1/x is a decreasing function, right? Okay, so the reciprocal, when you do the reciprocal, you have to flip the inequality sign also. I hope it makes sense. Okay, not only when we multiply or divide by -1, by negative number, the way we learn in chapter 1, it is actually in general, we see the function that makes the motion. Okay, applying negative, basically y equals to -x, that's decreasing function. Doing reciprocal, that's also decreasing function. So we need to reverse inequality sign. Okay, now this question that we have just now here, give me a second, let me erase this, happens to be natural log. The one we have here happens to be natural log, which base is greater than 1. So natural log is still increasing function. That's why we maintain, we keep the inequality sign without reversing it. Okay, but if this were log base, let's say 1/2, for example, then you cannot do so anymore. You need to reverse inequality sign. Now, of course, if you have a choice of choosing which base you use, you will use either natural log, base E, or log base 10, right? Nobody will be silly enough to purposely use base 1/3, for example, right? Even though that's okay, I cannot mark you wrong for that, okay? But I just think like, hey, you know what? You want to be strange, you want to be different from somebody, make sure it's elegant, okay? Make sure it's elegant. Do not be different simply because you want to be different. No, you be different in a way that people will see, oh, you know what, that's a good different, okay? Do not degrade yourself. Do not degrade yourself. Okay, now from here I go on further. I will solve for t, right? Now, but here I will divide by 0.8. Notice that 0.8 is negative. So if I divide by natural log of 0.8, that's a negative number, by the way. So t is less than equals to natural log of 0.5 over natural log of 0.8. Okay, so how long does the drug in your body be more than 2 milligrams? That's when T is at most this number. So when you compute log, natural log of 0.5 divided by natural log of 0.8, I get, why I get different number? Oh, you know what? This should be 0.2. Well, what am I doing? This is 0.2. I get T is 7.21257. So approximately 7.2 hours. I hope that explains the following. This number and this function, of course, is hypothetical. Yeah, this number is hypothetical. Okay, this function is hypothetical, but it's close enough to how the medicine actually works in our body. Okay, for let's say you have some headache, right? Let's say you have some headache after the test, you have some headache, let's say, okay, and then you take the medicine. Okay, let's say you take Tylenol, and Tylenol says that take it at most every 8 hours. Okay, why 8 hours? Because of the following. The medicine that you take, let's say Tylenol, how many milligrams? Let's say 100 milligrams. Okay, they give you 100 milligrams because of what? They want that medicine to be effective in your body for, let's say, 8 hours. Okay, so they already did the computation that in 8 hours, let's say in 8 hours, you still have that Tylenol in your body at least 20 milligrams. Okay, once it falls below 20 milligrams, some people will start feeling the pain again. Does it make sense for you? So what you can do, what you can do if you want to have longer, let's say you want to have, let's say enough Tylenol such that for the next 24 hours, you have more than 20 milligrams in your body, then you may take 300 milligrams. If you take 300 milligrams, I don't know, I just guess. Okay, if you take 300 milligrams, then in 8 hours, you have approximately 60 left. Okay, and then the next 8 hours, you have approximately 12 left. So now 300 milligrams is not enough. Okay, if you want it to be at least 20 milligrams for the next 24 hours, you actually need to take 4 times that. So for the next 24 hours, you have at least 20 milligrams in your body. Is it okay? I just make up numbers. Now, the thing is this, but if you take 400 milligrams of Tylenol at once, your liver may be working too hard. Does it explain something? Okay, so the medicine should be kept at some minimum level in your body to be effective. Okay, after a certain time, because you pee too much, then the drug actually being released from your body too early, right? Okay, but if you take too much at once, your liver and your kidney will be working too hard. So there's a trade-off there. With this knowledge, then I usually tell my wife when she has headache, because she's on the smaller size, right? Okay, so instead of getting the full dose of Tylenol, if she has headache, I tell her, okay, you know what? Instead of getting one dose of Tylenol for 8 hours, what I told her to do is to take half dose every 4 hours. Okay, this way then her kidney and liver does not need to work too much. Okay, of course it also has something to do with the weight though. That's for part A. So you see that it's actually more interesting when you start talking about application, right? Okay, part B. What is the half-life of the drug? What is the half-life time? What is half-life time? Half-life time is the time such that the amount of drug in your body is only half of the original one. That's usually denoted as T half. That's the time such that the amount after that T half is equals to 1/2 the original amount. Okay, so in this case, what is the half time? So A of T half will be 1/2 of the original amount, which is 10, right? The original amount is 10. Now you set that equals to the function. Equals to 10 times 0.8 to the t. So 5 equals to 10, 0.8 to the t. 1/2 equals to 0.8 to the t. Apply natural log. So natural log of 1/2 equals to t times natural log of 0.8. Okay, so t is equal to natural log of 1/2 over natural log of 0.8. By the way, natural log of 1/2 is negative natural log of 2. Then from there, you use your calculator. Okay, you can use your calculator from here already, actually. So this is 3.10628 hours. So in 3 point something hours, only 5 milligrams left, at most 5 milligrams left in your body. Now, let me talk about this further. Let me talk about this further. This equation, this function, AT equals to 10 times 0.8 to the t. I said earlier that this actually follows very closely the model, pretty closely the model of how the drug stays in our body. Okay, let's take a look on when t equals to 0. So you will see that the initial amount of the drug is always the coefficient. Okay. Next, in 1 hour, how much left? In 1 hour, only 8 units left. So you see that 2 milligrams actually being released through the urine. Okay. In other words, 80% retain per hour. In other words, 20% released. Now, I don't have any plan to ask you questions how to set up an equation. Okay, I may give you the coordinates, right? But from here, we can actually say is the following. Once they tell us the following, initial amount, (10 milligrams), 20% release each hour. From there, we get right away the amount left in our body at time t will be 10 times 20% relief means 80% maintain, right? That will be the equation. That will be the function. Now, from here, you also I hope you also realize that at any time, you must have that drug in your body, even though maybe the level becomes very, very small. Okay. For example, how much, what is the amount of that drug in your body after 24 hours? After 24 hours, then the amount of that medicine left in your body is 10 times 0.8 to the power of 24. That is 0.047 milligram. But it is still there. Well, of course, if this is headache medicine, a Tylenol, this small amount in your body will not be effective in helping you with your headache anymore, right? But it is still in your body. It is still in your body. What happened after 7 days? Then the amount of that Tylenol in your body will be very, very small. That is 5.237 times 10 to the negative 16. Very, very small already, right? Milligrams. Near zero. Near zero. But it's still there. You know, it's still there. In other words, if you think about it, it follows exponential function whose base is less than 1 but positive. Sorry. It will start from t equals to 0, which is 10 milligrams, and it dies down. But never touch x-axis. Never touch x-axis. Okay, now, if I change this Tylenol, and change it to some drugs, illegal drugs, let's say some marijuana, let's say, which is now legal, okay? But one of the questions I get when I went to Marine was, had you had marijuana in the past? It was in year 2000, by the way, 20 years ago. So they asked me that question, have you ever had marijuana? I say no, I mean, I never used that, okay? But some of my friends in the company at that time, in the same group at that time, say that I had that more than 4 years ago. Okay, now, and the drill instructor says, the recruiter says, if it is more than 4 years ago, you're fine. But in the last 4 years, did you do it? Did you do that in the last 4 years? And one person say yes. Okay, then you need to wait. You need to wait until 4 years already passed. Now, you may question why 4 years? Why 4 years? If you had marijuana in the last 4 years, then you need to wait until you are clear for 4 years straight. But why 4 years? Because 4 years tell us this number here. Do you see that? Okay. And Marine Recruit Depot at that time has the, when they test your urine, the test is sensitive enough to catch any amount of marijuana left in your body, even though it's very, very, very small. Now, the thing is, it is sensitive enough to detect that even if you use that in the last, basically around 40 months. I hope that explains how the drugs actually works compared to the sensitivity of the test they have. You see what I mean? I don't use marijuana. I'm someone who against that. Okay, I'm someone who against that. But if you do that, don't worry about it. I'm nothing against. I'm against the use of that. But if you use that, that's your freedom. Okay, that's not my right to tell you what to do outside of the classroom, outside of math, right? But I'm telling you about how the tests in Marine Corps, and of course in other places also, when they test your history of using illicit drugs, What is the science behind it? They actually use approximately this kind of formula. Okay. And if their test is sensitive enough, then even the amount that is very, very small, they still catch that. Okay. Basically, once you take any drugs, there must be some residue left in your body. Okay. Including if you smoke. If you smoke, the nicotine will stay in your lung. In fact, it will stay more. Your body will retain a lot more when it comes to smoking. Okay, so imagine if you smoke for heavy smoker like my brother for more than 30 years, you can imagine his lungs actually really, really, really dirty. Okay, well, anyway, this is my little explanation about drugs. This model here can be used even for radioactive decay. So if you look for problems in this section, some of them may be about radioactive decay, then it's basically the same idea. Okay, of course, the numbers will be very different. Okay, but because it is exponential function, then for t goes to infinity, it is still positive. Okay. Now, let me go on to the next section. Did I suggest you suggested homework here? 4.1. I don't know if in my lecture I provide suggested homework, but let me also provide that here. From number 1 to number maybe 47, 49, 49. Just do the odd ones. Now, if you are going to take chemistry later on, take a look on number 51. And 53, if you are going to take a business major, econ major, number 55 and 56. If you are going to take physics major, number 57, 58. If you are going to biology major or medicine, pharmacies, you look at this. Okay. And of course, there are a lot more on the application. Yeah. But the main one that I need you to work on, the basic one, you have to know this. Okay. Number 51 and on, the word problems is really, they tell us the function. Okay. And we just do the interpretation of those and how to get what they want. Okay. 5.1. Chapter 5 on trigonometric functions. It's the first section is on angles, which you have learned in your geometry. So I will go over this section quite fast, except for the last two topics, maybe the last three topics, but the first two topics are topics that you have learned in your geometry. Okay, let's review a little bit. Angles in standard position. And coterminal angles. Angles in standard position, it refers to the angles that is measured from positive x-axis counterclockwise. Angle theta is in standard position, if it is measured from positive x-axis. So first from positive x-axis and second counterclockwise. Now, why do they start with this? So that every time we say the angle, unless otherwise stated, that angle must be understood as in standard position. Okay, so when somebody tell you, imagine angle 60 degrees. When we say 60 degrees, that person don't need to say anymore, or 60 degrees from where? From the y-axis. Do you go clockwise or counterclockwise? Clockwise. No. From now on, when we say 60 degrees, it is clear. It must be from positive x-axis going counterclockwise. Okay, that's what it means. Okay, I have this from previous students though, not you, of course. I don't even remember when was that. It was a long time ago. When I say what is sine 60 degrees, I have that students ask me, but Thomas, you were not clear from which, 60 degrees from where, which direction? And of course, you have these kind of students who think they are so smart to question everything, but that actually tells us that this person didn't study. Because if I don't say anything else about that angle, then that angle must be in standard position. Okay, unless otherwise stated, then every angle in this course will be in standard position. Okay, so when we say 60 degrees, I don't need to say further, oh, from which side? Is it from positive x-axis, negative x-axis, positive y-axis, negative y-axis? Is it clockwise or counterclockwise? No, no need. It is always positive x from positive x-axis going counterclockwise. That is the reason our quadrant system is called quadrant 1, quadrant 2, quadrant 3, quadrant 4. Because the angles is counted counterclockwise from positive x-axis. Okay, so the way we measure this angle already adjusted with the way we actually did our quadrant system. Okay, that's one of the consequences. I'm not saying that quadrant system comes from here. No, I'm not saying that. Quadrant system, quadrant 1, quadrant 2, quadrant 3, quadrant 4 actually came first. We learned that way before we learn about angles, right? What I'm trying to say is the way the angle in standard position being defined to us is being defined in a way such that it match with the quadrant system that already there, already in place. Okay, now that's what angles in standard position. Now, what is coterminal angle? Coterminal angles, angle theta 1 is coterminal to angle theta 2 if they ends at the same terminal site. So let's say our 60 degrees, is actually coterminal to 60 plus 360 degrees. Let's see, which is 420 degrees. Okay, in fact, every angles, from there we see that angle 1 and angle 2 are coterminals. We use this notation if they differ by multiple of 360 degrees. So to get another coterminal angle, all you need to do is to keep on adding 360 degrees, keep on subtracting by 360 degrees. Okay. Now, complementary angles. Complementary supplementary angles. Two angles are complementary if they add up to 90 degrees. Angle A plus angle B equals to 90 degrees. Basically, they form a right angle. Supplementary angles if they add up to 180 degrees. Okay, that's to remind us about complementary and supplementary angles. Now, something maybe new for you is the radian measure. What is radian measure? Now, suppose I have, you know what, I use different color. Okay, now radian measure is as the following. Now we get used to angle measure, right? Angle theta. Okay, angle theta in degrees. Now, theta in radian, I don't use degree sign, is equals to the ratio of the arc length to the radius. Okay, so instead of using theta degree here, let me just use theta. Now it is in radian. Is the ratio between the arc length, we usually denote that by S, over the radius R. So theta equals to the arc length subtended by that angle to the radius R. Now, what it has to do with our angle actually, let's see it this way. Let's take a look on one full circle. One full circle. We know that's 360 degrees. Okay, that's the angle in degrees. This is angle in degrees. What is the angle of one full circle in radian? In radian, that will be theta equals to the circumference 2 pi r over the radius r. So for one full circle, the angle will be 2 pi in radian. In other words, the 360 degrees we know as one full circle before, in radian is 2 pi radian. Now, it is a custom correctly that when the angle is in radian, sometimes we write the radian, sometimes we don't. So it is correct to write 360 degrees is the same to 2 pi without writing the radian. Okay. From here, you see that the degree signs with degree signs and without degree sign is totally different. Okay. 30 degrees and 30 are not the same. 30 degrees is not the same to 30. Why? If you just write 30 without the degrees, it means it is in radian. If you don't write the degree sign, it must be in radian. Okay, now furthermore, if 360 degrees is 2 pi, then half of that equals to pi. 180 degrees is equivalent to pi radian. Now, this gives us the conversion we need later on to convert from radian to degree or from degree to radian. Okay, that's what we will do later on in our exercise. But from here, let's do some important angles like 90 degrees in radian, that will be pi over 2. 60 degrees in radian will be pi over 3. 45 degrees in radian will be pi over 4. Now you may say, Thomas, you are way too fast. Don't worry. Let's visualize that now with a circle. Now, 0 degree is the same to 0 radian. 180 degrees is the same to pi in radian. Now, imagine that 180 degrees as pi, then half of that pi is 90 degrees. Another half of that 90 degrees is 45 degrees. Which is pi over 4. Now 60 degrees is 1/3 of a 180 degrees. That's pi over 3. And so on and so forth. Okay? And so on and so forth. Now later on, I will give you the table or the chart at which you need to, and let me just give it to you now. I need you to memorize the special angles as soon as possible after your test 2. Okay, so 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. You have to memorize what those are in radian. Okay, now let's say on Thursday evening, this is what you memorize. And then Friday morning, you will memorize the rest. Memorize the rest. What happens if you have 45 degrees in quadrant 2, 60 degrees from negative x-axis in quadrant 2, 30 degrees from negative x-axis in quadrant 2. Okay, what will the angles be? And what will those be in radian? Okay, this is 135 degrees, which is equivalent to 3 pi over 4. This is 120 degrees, which is 2 pi over 3. 150 degrees, which is 5 pi over 6. Okay. And also the rest. Okay, memorize this. On Tuesday next week, then I will give you a table that I want you to print out. You know what? Let me do it now. Let me do it now. I'm referring to, give me a second. I'm referring to this one. I hope I have that on my file list here. This one. So try to find out what are the angles. I will post it on our discussion board later on. I need you to fill this in and visualize, of course, the angles in degrees and the angles in radian. Okay, print this out. Maybe you print some of them out, not only one, and then fill that in. Okay, the angles in degrees, angles in radian. Okay, angles in degrees and angles in radian. Give me a second. Oh, hold on. Why I cannot do that one? Too big. Okay. Yeah. Let me post it now. Let's take a break. We come back at 9:35. While I post this file on our discussion board, then we will start working on problems from our textbook. Okay, let's start again. I already post this file on our discussion board here. Okay, so please print this out, maybe print 5 or 6 of them and practice with memorizing, practice, and then hopefully you memorize from there. Okay, when it comes to trigonometry, visualization will be very, very useful. So I would like you to learn to visualize that, the information instead. Okay, the picture tells 1,000 words, right? Okay, now let's start working on problems from our textbook. Yeah, at this point we can do most of that already, the one I taught you. Let's say, for example, number 2. This is from page 331, number 2. If the given angle is in standard position, so part A, 240 degrees, this is in standard position, find the 2 positive coterminal angles and 2 negative coterminal angles. 2 positive coterminal, you add 360 degrees. At 360 degrees, that will give you 600 degrees, plus another 360 degrees, that's 960 degrees. If I want the negative part, subtract by 360 degrees, I will get negative 120 degrees, and subtract another 360 degrees, that's negative 480 degrees. Pictorially speaking, 240 degrees is located here. Now this is 240 degrees. Now negative 120 degrees is basically from positive x-axis, but you go clockwise instead. Okay. We go clockwise because it's negative angle. So this negative 120 degrees is still in standard position. Okay. Now what happens if the angle is in radian? Let's say number 4b, 2 pi over 3. Now, if it is in radian, then we will add 2 pi. Okay, but your fraction should be good though. 2 pi over 3 plus 2 pi is what? Let me do it aside here. 2 pi over 3 plus 2 pi. We need to do LCD, right? That's 8 pi over 3. Okay, plus 6 pi over 3 again, that will be 14 pi over 3. If we want the negative angle, means we subtract by 2 pi. If you subtract by 2 pi, that will be negative 4 pi over 3. Subtract by 2 pi again, that will be negative 10 pi over 3. So all these 5 angles here are coterminal. Okay, all these 5 are coterminal. You basically keep on adding 360 degrees or subtracting 360 degrees. In radian, you add or subtract 2 pi. Number 6. Find the angle that is complementary to theta. So if theta is 76 degrees 4 minutes 53 seconds, what is the complementary angle? Let's say the complementary angle is angle gamma. That will be 90 degrees minus theta, right? That's 90 degrees minus 76 degrees 4 minutes 53 seconds. Now this notation here is called DMS style, or sometimes we call that DMS form. D for degree, M for minutes, S for seconds. Now, how do we subtract this? We know that 1 degree is 60 minutes and 1 minute is 60 seconds. Okay, so how do we compute these timers? Let's convert that 90 degree first. That 90 degree, I break it into 89 degrees plus 1 degrees, right? But the 1 degrees, I write it as 60 minutes. Now that's 60 minutes. I borrow 1 minute. I make it 60 seconds. In other words, this is the same to 89 degrees, 59 minutes, 60 seconds minus 76 degrees, 4 minutes, 53 seconds. Like when we do borrowing, you know, instead of base 10, we now use base 60. This becomes 13 degrees, 55 minutes, 7 seconds. What happens if it is in just degree with decimal form? Theta equals to 5.08 degrees. So the complementary angle, the complement will be 90 degrees minus 5.08. Then you can just use calculator. Actually, you will get 84.98 degrees. I'm sorry, 92, not 98. Now, likewise with supplementary angle means they add up to 180 degrees. Number 8a, if the theta equals to 125 degrees, 16 minutes, 27 seconds, then the supplementary angle will be 180 degrees minus that angles in DMS. I borrow 1 degrees, becomes 60 minutes. Now borrow 1 minute becomes 59 minutes, 60 seconds. Okay, so this is 54 degrees and then 43 minutes and then 33 seconds. I'm sorry, that's number 7a. 7b, very similar to that. If the theta is 58.07 degrees, then what is the supplementary angles? Just subtract that directly. Now the next thing is how to convert angles from degrees to radian. Let's say number 10. If I have 120 degrees, what will that be in radian? To convert to radian, we will multiply by pi over 180 degrees. Now why? Because we know 180 degrees equals to pi, equivalent to pi. Okay, so the ratio should be 1, right? Pi over 180 degrees will be 1. Now, so we will play with that pi over 180 or later on 180 degrees over pi. Now, how do we know we multiply by pi over 180? Because we want to cancel the percentage. I'm sorry, cancel the degrees, right? So the degrees has to be at the bottom. Now, then you reduce the 120 and 180. Both of them multiple of 60. So this becomes 2 pi over 3. Okay, to convert from degree to radian, multiply by pi over 180 degrees. Suppose another example, 135 degrees. What is that in radian? Multiply by pi over 180 degrees. Okay, such that the degree cancels, right? And 135 degrees, 180 degrees, multiple of 45. This is 3, this is 4. So this is negative 3 pi over 4. 210 degrees, that's equivalent to multiplied by pi over 180 degrees, cancel the degrees, and 210, 180, both of them multiple of 30, so this is 7, this is 6. This is 7 pi over 6. And just leave the pi. Do not use calculator and make it ugly decimal. No need. Just leave them in pi. Okay. In general, if we want to convert to radian, that's what we do. We multiply by pi over 180 degrees. On the other hand, if we move from radian to degrees, let's say number 14. We have 5 pi over 6. From radian to degrees, you multiply by 180 degrees over pi. That's how we will gain the degree sign. That's how we will gain the degree sign at the end. Okay, we'll get the degree sign at the end. And in between, cross cancel whenever possible. Okay, here we can cross cancel the pi, 180 divided by 6, that's 30. So this is 150 degrees. Part C, 11 pi over 4. What is that in degrees? That's 11 pi over 4 times 180 degrees over pi. Cancel the pi. I can reduce by 4 here. This is 45. So this will be equal to 495 degrees. Okay, next, the following is difficult. Number 18. We have the theta equals to 3.1. No degree sign, it means it is in radian. No degree sign means it is in radian. Now we want to convert this to DMS style. Convert to DMS style. What I will do first, I will convert to the degree first. Okay, I will convert to degree first. How to convert to degree? Multiply by 180 degrees over pi. That way I can keep the 100, I can keep the degrees. I get this is equal to 177.61692 degrees. Now, when you divide by pi, use the pi from your calculator. Don't use 3.14. Too much rounding later on. Use the pi from your calculator. Let me share that with you. Give me a second. Yeah, use this pi here. My pi, I used TI-84. So I have this pi here. Okay, right under the clear. Okay, so the way I get this number is by 3.1 times 180 divided by pi. That's how I get it. Okay, that's how I get it. Now, then I will change these degrees into DMS form. This is 177 degrees plus 0.61692 degrees, right? Now multiply that by 60 minutes. So this the decimal part of these degrees multiply by 60 minutes. That will be 177 degrees plus, let's see here, subtract that y by 177. Now multiply by 60, 37 point something, 37.01499. 37.01499 minutes. Now then, you take the 37 minutes away. You change that decimal part of that minutes, multiply by 60 seconds. Okay, so this guy here, subtract by 37, okay, multiply by 60 seconds. 0.89937. So 177 degrees, 37 minutes, 0.899 something 37 seconds. Now our textbook, I believe, will make it 177 degrees, 37 minutes, 1 second. Okay, because they round it to the nearest seconds. When do we use this DMS style, Thomas? We don't really use that anymore in daily life, but it will be fun if you actually take a flight to a place, or at the door, or at the when your plane parks, then you will see that actually at the right in front of the plane. Let me show you what I'm talking about. Plane parking position. Do they have that? Plane DMS. Hold on. Give me a second. Terminal. I'm looking for it. Give me a second. I always see that every time I play in parks. Maybe this one. So they still use decimal for, they already moved to decimal, but I see the DMS style when the plane parks. I can't really tell what's the term they use. Longitude, latitude, DMS. No, this is not what I want. Images. I don't have that here. DNS plane. Will I get it though? I still don't get it. I'll try to look for the picture. But every time my plane land, when my plane lands and park, then right at the gate of that plane, where the plane stopped, we will see that though. DMS plane stop. I need to stop playing with this. For me, it's fun. Every time I see that, say, hey, that's what I teach, you know. I will try to find it out later. Okay, so basically what happened with converting from radian to DMS style, in between you need to convert that to degree first, which is this guy here. Okay, now then you take the decimal part of that degree, multiply by 60 seconds, give you the seconds. Then you take the decimal part of that minutes. I'm sorry, I should say minutes. Decimal part of that minutes will give you the seconds. Okay. Now part D. So I believe I did the conversion already. Now arc length. Part D, arc length. And area of sector. The arc length is easy. Suppose I have a circle. Okay, and we need the arc length. We need the arc length S of that circle. Let's say this is the angle theta, and this is the S, the arc length, and this is the R. Okay, now we know that theta equals to S over R. As long as theta, emphasize theta has to be in radian. It has to be in radian. Therefore, the arc length is basically theta R. the angle times the radius, but the angle has to be in radian. Okay, now how about the area? The area of the sector, this is what we call the sector. Okay. Area of the sector is equals to 1/2 theta r squared. Now this demands a proof. Why the formula looks like that? Now we know that the area of a sector is proportional to central angle. The larger the angle, the larger the area of the sector. If you double the angle, then the area of the sector will get doubled also. Okay, so let's compare that with the area of the circle, which we know is pi r squared. Okay. Oh, I'm sorry. We know the area of the circle is pi r squared, but the central angle is 2 pi. Okay, so the area of the sector will be theta over 2 pi times the area of the circle. So the sector area is equal to theta over 2 pi times pi r squared. That's how we cancel the pi. We get 1/2 theta r squared. That's the proof. Oh, by the way, we also know that theta r is equal to s, the arc length, right? So if I rewrite this, this is 1/2 theta r times r. This guy becomes arc length. So the area of the sector can also be written as 1/2 SR. The arc length times the radius. Okay, now with that said, let's take a look on number 30. The arc length is 3 kilometers. The angle theta is 20 degrees. Oh, hold on, that's not in radian. Change it to radian. That's 20 degrees times pi over 180 degrees. That's pi over 9. The question is, what is the radius? S equals to theta r, S is 3, the theta is power over 9 times the radius. So radius is equals to 3 times 9 over pi. Three times 9 over. Am I okay? Why I feel like I did something wrong? Yeah, I'm fine. Okay, so then that's 27 over pi. And just leave it like that. Okay, just leave it like, at least you give me that exact solution first, and then you use calculator. 27 divided by pi, what's that? That's 8.59347. Okay, but I prefer you to just give me the exact solution. If you want to give me the approximate solution, get this first. Okay, get the exact solution first. Okay. Now, with this said, that's the question, right? Find the radius. I can have a follow-up question, part B, find the area of the sector. Find the sector area. That's 1/2 times theta r squared. 1/2 times theta, which is pi over 9. And r squared is 27 over pi squared. Okay, that's actually harder to compute that way. You can use that one. We can also use 1/2 s times r, where the s is 3, the r is 27 over pi. Okay, so that's 81 over 2 pi. That's faster, right? Okay, you can also use this one though. So you see one of the pi cancels, one of the 9 cancels, right? So we get 81 over 2 pi. Okay, that's the sector area. Number 43 is a quite interesting question. I wonder if I usually have done that in my... Let me do number 42 instead. I think number 42 is more interesting. Number 42. A hexagon is inscribed in a circle. What is a hexagon? Now, you took geometry before, so you're supposed to know what a hexagon looks like. Hexagon looks like this. Six-sided, and I try to make it regular, but it's kind of hard if you don't give me enough time, right? Well, approximately this is what a hexagon. Now, number 42, a hexagon is inscribed in a circle. Inscribed in a circle, so it will look like approximately like this, maybe. Yeah, it's inscribed in a circle. Okay, now if the difference between the area of the circle and the area of the hexagon is 24 meters squared, the difference between area of the circle minus the area of the hexagon is 24 meters squared. Now that area, difference area refers to this. Okay, use the formula for the area of the sector to approximate the radius of the circle. What is the area of a hexagon? What is the area of a hexagon? Anybody remember? This is 60 degrees, right? Okay, so one of the triangle, if this is R, and this is 60 degrees, it means the height is radical 3 over 2R. So the area of the isosceles triangle will be 1/2 times the base is R times the height is radical 3 over 2. No, it's not. Radical 3 over 4 R. Am I right? Oh, that's right though, radical 3 over 2. Yeah, so the area of isosceles triangle, memorize this formula, radical 3r squared over 4. So the area of hexagon will then be 6 times, there are 6 such triangle, radical 3r squared over 4. That is 3 radical 3r squared over 2. Now coming back here, this is pi r squared minus 3 radical 3r squared over 2 equals to 24. Factor the r squared. So r squared equals to 24 divided by pi minus 3 radical 3 over 2. That is, if I multiply the top and the bottom by 2, I get 48 over pi, 2 pi minus 3 radical 3. So the final answer will be, the r will be square root of 48 over 2 pi minus 3 radical 3. Then from there, you use your calculator, but at least I get the exact solution already. Okay, I use my calculator. 48 divided by parentheses 2 pi minus 3 radical 3. That's r is approximately square root of 44 something. That's 6.64507 meter. Okay, the last part of this section, linear speed. And angular speed. Suppose we have a point on a circle traveling from one point on the circle to another point on the circle. Let's say this is P, this is Q, and angle theta, this is S, this is radius. Okay, so if distance traveled is S, from point P to point Q, the distance is S, and the time is T, then the linear speed denoted by phi is S over T. Now, if during that time you travel theta and the angle theta, then the angular speed denoted by omega looks like a W, but not really a W. This is W, right? Now omega looks like this. Okay, omega. That's the angular speed. That is theta over T. The angle that you travel divided by the time. This is the linear speed. And this is angular speed. Okay. Okay, now we know the distance s is equals to theta r over t, right? I mean, the s is theta r. Now, theta over t is our omega. So we can also write and conclude that linear speed is basically the angular speed multiplied by the radius r. Let's take a look on some geology, number 45. The last question for the day. Earth rotates about its axis once every 23 hours, 56 minutes, 4 seconds. It's not exactly 24 hours, by the way. It's not exactly 24 hours. It's a bit off. And I think in the last 1 week, I read an article that our Earth rotation gets a little bit faster, a couple milliseconds recently, because of one of the earthquake. I don't remember which earthquake was that. But yeah, because of something happened such that our Earth is rotating slightly faster. So even this number is not accurate though. Okay, it is a lot more accurate than our 24 hours. Okay, but it is not 24 hours. Okay, I will go back to that. Okay, I will go back to that. Now, approximate the number of radians Earth rotates in 1 second. So find the omega. Find omega in radian per second. Okay, so omega will be the angle traveled in 1 rotation, which is 2 pi, divided by the number of seconds we have. That is equals to 23 hours times 3,600 plus 56 minutes times 60 seconds plus 4. I get this is 86,164 seconds. So 2 pi divided by that number, 2 pi divided by that number is 0.000072912. Now, in scientific notation, that will be 7.29212 times 10 to the negative 5, which means this 7 here is at the 5th decimal place. Okay, 1, 2, 3, 4, 5. Actually, I want to say something more about this. About the fact that the Earth rotates around its axis every 23 hours, 56 minutes, 4 seconds. Let me just consider this as 23 hours, 56 minutes. Okay, instead of 24 hours, it's actually 4 minutes less. Now, this explains the following. If you are going to astronomy, I'm not in astronomy field, but we can explain the following. The Earth rotates around itself, around its axis, every 23 hours, 56 minutes, right? Okay, so what happened is this. Let's say today you look at the star, one particular star in the sky. Let's say right now at 10:22 p.m. Okay, now then tomorrow you will face the same star exactly in the same position 4 minutes earlier. Next day you will see the same thing, exactly the same thing, but not at the same time. Not at the same time, but 4 minutes earlier. So the next day you will see the same star at the same position at 10:18, 4 minutes earlier. Because of that difference. Okay, that's one. Now, another reason, another implication of this difference is the following though. This is the one that applied to us. How many days we have in a year? 365 days. Right? Okay, 365 days, every day 24 hours. Every hour will actually 4 minutes ahead. Right? Okay, now if you multiply this and divide by 360, I'm sorry, divide by, okay, let me multiply this first. 365 days times 24 days. Every day we are ahead 4 minutes. That's 35,040 minutes. In 4 years, we will accumulate this many days, this many minutes. I'm sorry. No, I don't need to multiply by 24. That's every day though. I'm sorry, I don't need to multiply by 24. So every day we accumulate 4 minutes, right? So in 1 year, we'll be ahead 1,460 minutes. In 4 years, this is in 1 year. In 4 years, we'll accumulate 1,460 times 4. That is 5,840 minutes. Okay. Now, this give us how to say that? This becomes the reason why we need a leap year. (366 days), right? The extra 1 days, to adjust. Basically, we slow down by 1 day because every 4 days it makes approximately that 24 hours. Okay, let me see the computation. Do I compute this right? Yeah, it has something to do with this. It has something to do with this. I need to stop here. That's why kind of like my mind is not working well anymore. But that gives us the reason for leap year, because one day supposed to be 24 hours, but it's a bit shorter. It's 4 minutes less. So in 1 year, we accumulate so many minutes, which later on we offset that with 1 extra day in every 4 years. Okay, I will stop here.